Hello there, Mr. Sutton here, bringing you the IM3 Chapter 2 Quiz 2 Extra Practice Number 3 solutions on review of advanced factoring techniques. For this one, we have a puzzle we're going to look at associated with this extra practice. For this one, we have two riddles we're trying to solve. You may have heard that old math teachers never die, they just reduce to lowest terms. We're trying to find out what happens to old lawyers and skiers. Old lawyers never die, they just blank. And same thing here with old skiers never die. What do they just do? So we're going to figure out this by going through this column of expressions in the middle. We have to factor these and find the answer for 1 through 7. It'll be here on the left. For 8 through 14, it's going to be over here on the right side. And when you find the letter that goes with the number, just put it above that number in these blanks here. So for example, we do number 1, and let's say that we figured out that the answer was, I don't know why. It definitely isn't, but let's say it were. So then we would put a y next to the 1 up here. And some of these numbers may appear more than once, so we also have to be wary of that. I see this 14 appears multiple times. Maybe I should start with 14. I don't know. Let's start with 1, and let's see what this puzzle gets us. First problem, I've got the expression 2x squared plus 22x plus 36. Since I don't have just one x squared, I'm going to see if I can take out a common factor before I try anything else. These are all even numbers out in front of my variables, so let me take out a 2. That leaves me with an x squared. 22 divided by 2 is plus 11x, and then 36 over 2 gives me an 18 there. Now, since I do have a 1x squared situation inside this parentheses, I'm just going to look for factors of 18 that add up to 11. So 1 and 18 won't work. 2 and 9 works. So I've got the 2 that I took out initially, and for the 2 that I add to 9 to get 11, I'm going to have x plus 2 as one of my factors, and then x plus 9 for the other factor. Looking over here on the left side to see if I can find that expression, I see that I've got 2x plus 2 and x plus 9 for letter T. So let me find spot number 1, because we just did question 1. Here's spot number 1, and that's the only one of the 1 there. Let me put a T above that. For the next problem here, I've got the same situation. This is not just a 1x squared situation, but I do notice that all of the coefficients, 5, 10, and 40, are divisible by 5. So I can at least take out a 5 for the numbers. Now, you might also notice that these all have at least an x to the first power. So let me take an x out as well. So 5x cubed divided by 5x, 5's cancel, x cubed over x is x squared, and then negative 10 over 5 is negative 2, x squared divided by x gives me x, negative 40 divided by 5 is going to give me negative 8, and then those x's cancel. On the inside, I've just got 1x squared, so I can use my little trick where I find factors of one thing that add up to something else. In this case, factors of negative 8 that add up to negative 2. 1 and 8 doesn't work, but 2 and 4 gets me negative 2 if I have a positive 2 and a negative 4. So I've got the 5x that I took out in the beginning. I've got an x plus 2, and then I have my x minus 4. So let me find that over here. There's a 5x, but the rest of it's different. Here's another 5x, x minus 2, x plus 2. Looks like that works. So I'm going to put an A in spot number 2. So here's one of those spots. And it turns out there's another spot with a 2 underneath that I'll have to put the A in as well. So we always want to look out to see if we can use something more than once. I noticed that we have an 18 and a 98, both of which are divisible by 2, and I think that's about as good as we can do for common factors for the coefficients. They also both have an x that I can take out. So we'll take out a 2 and an x, and then 18x cubed divided by 2x, that's going to be 9x to the second power. Negative 98x divided by 2x, that's going to be negative 48, or 49 rather, and the x's cancel completely. So now looking inside this parentheses, I do notice that 9x squared and 49 are both perfect squares. This is something in the format of a squared minus b squared. So for a squared minus b squared, we can split that up by square rooting each of those things and putting them in a plus and minus parentheses. So we got the 2x that we took out initially. Square root of 9x squared is 3x. Square root of 49 is going to be 7, so I'll do 3x plus 7 and 3x minus 7. And let me see if I can find that over here. It looks like that's going to be D right there. So D is going to go above blank number 3, and there's just one of those right there. This problem is a little bit wacky because we've got two different letters going on, an A and an X. I do notice that all of these have an A, so I'm going to factor A out of everything, and I think that's about as good as I can do. That leaves me with just x squared minus 7x plus 12. Looking at what's inside the parentheses, I have a 1x squared situation, a equals 1, or if the coefficient of x squared equals 1. So I'm looking for factors of 12 then that add up to negative 7. So let me think here. 1 and 12 doesn't work, 2 and 6 doesn't do it, 3 and 4 works if they're both negative. So I've got the a I took out initially, I've got x minus 3 and x minus 4. Looking for that over on the left, there's an a, but I don't have the correct factors next to it, so let me keep looking. There's another a way down at the bottom, and I've got the x minus 3 and x minus 4. So it looks like e is what I have to put above all the 4s, of which there are 3 of them, ironically. So there's an e going here. Here's another 4, so there's an e there, and an e over here. I mean, I guess e is a pretty common letter, so it makes sense that there would be multiple of those. For number 5, it's looking like I have an x to the 4th, an x cubed, and an x squared. So definitely I can take an x squared out of all 3 of those. That'll leave me with an x to the 4 minus 2, so x squared. This will be 8x to the 1st, and then the x squareds cancel, leaving me with just negative 20 for that last one. Since I have a 1x squared situation inside my parentheses, I can look for factors of negative 20 now that add up to 8. So 1 and 20 won't do it. 2 and 10 works if I have negative 2 and positive 10. So here's the x squared I took out. I have an x minus 2 and an x plus 10. And here's an x squared. There's my plus 10. There's my minus 2. So I'm putting an s in spot number 5 right there. And I think that's the only 5 out there. So we're done with this one. On this next problem, I have something that's not a 1 out in front of my x squared. Let's see here. I can't take out a 3 from everything. Nothing's divisible. There's no common factors at all, actually. So I'm going to go to the AC method for this one. So 3 times 10, that gives me 30. So now I'm going to be looking for factors of 30 that add up to 13. So 3 and 10 do the job. So I'll split up 13x into 3x and 10x. And then I can take, now I can group this thing because there's 4 terms. So 3x squared and 3x, I can take a 3 and an x out of both of those. 3x squared, that's just going to become an x. 3x divided by 3x is a plus 1. And now for my last 2 terms, I can definitely take a 10 out of both of those. So that leaves me with an x and a plus 1. I have an x plus 1 common factor that I can take out of everything. And then 3x plus 10, that's my other leftovers that I can set aside in another parentheses. So I need an x plus 1 and a 3x plus 10. Here's 3x plus 10, here's x plus 1, so that's w. And I'm going to put that in spot number 6. And it looks like there's just one of those right there, so there's a w. All right, let's check out number 7. On this one, I have a 10, a 25, and a 35. I can take out a common factor of 5, but that's about as good as I can do for that. These actually all have x's as well, so let me take an x out. 10x cubed divided by 5x, that's going to be a 2 and an x squared. Negative 25 over 5 is negative 5. X squared over x is just x. And then negative 35 divided by 5, that's a negative 7, and the x's cancel completely. Well, this is not ideal. The stuff inside does not have an x squared coefficient of 1. I've got a 2 instead. So I am going to have to use the AC method to get to the bottom, or guess and check, either way. I'll do AC. So 2 times negative 7, that's an AC value of negative 14. So I'm looking for factors of negative 14 that add up to negative 5. Positive 2 and negative 7 would do it. So I've got the 5x I took out, and then in here I've got 2x squared. I'm going to split this up into a plus 2x and a minus 7x. And then I still have that minus 7 there. So that was really the only change I made, was splitting up that negative 5x. All right, time to do some grouping on the stuff inside. So I have the 5x, I have a 2x that I can take out of those first two terms in there, and then that leaves me with an x and a plus 1. For the last two terms, I'll take out a negative 7, leaving me with an x and a plus 1. I've got the 5x still, don't want to lose that. Now inside here, I can take an x plus 1 out of everything, and then the 2x and the minus 7, that'll go in my leftover parentheses. So let me find that over here. We've got the 5x, here's the 2x minus 7, here's the x plus 1, so I need an I, and that's going to go in spot number 7. So there's a 7 right there, there's an I, and then I see actually another one down here, so I get to use that one twice. For this next problem, looking to see if I can at least take out any common factors, 12, 28, and 24, those are all divisible by 4, so let me start with that. And then that leaves me with a 3u squared minus 28 over 4, that's minus 7u, and 24 over 4 gives me minus 6. Well, on the inside, I'm going to have to use AC method or guess and check. So for AC, we've got 3 times negative 6, that's negative 18 for the AC. So I need factors of negative 18 that add up to negative 7. 1 and 18 doesn't work. 2 and 9 works if I have a plus 2 and a minus 9. So let me split up this negative 7u into a plus 2u minus 9u. So that's the only change from what I did before there. Now that I've got 4 things inside my big parentheses, I can do some grouping. So I want to keep that 4 that I took out initially out there. Inside now, 3u squared and 2u, I can take a u out of both of those, and that's about it. So that leaves me with a 3u plus 2. And then for negative 9u and negative 6, I can take out a negative 3 from both of those, leaving me with 3u plus 2, same thing as I had before. So I've got the 4 that I took out initially. I've got this 3u plus 2 common factor that can come out here. And then u minus 3 is my leftovers. Looking for that now, I've got a 4. Here's 3u plus 6, so that's a little different. I'm going to keep looking here. Here's another 4 out in front. 3u plus 2, u minus 3, that's the one I need. So G goes in spot number 8 right there, and that's the only 8. This next one's kind of wild. We have something in quadratic form, but it's not really a quadratic. We have x to the 4th, or u to the 4th, u squared, and then a constant. So I'm going to factor this as if it were a quadratic, a trinomial, but I'm going to use u squared instead of u in my parentheses. So I need factors of negative 4 that add up to negative 3. 1 and 4 works if I have a positive 1 and a negative 4. So I'm going to write u squared plus 1, and then u squared minus 4. That's great, but I can go a little bit further. The sum of 2 squares I can't break up at all, so that u squared plus 1 is done. But u squared minus 4, that's something in a squared minus b squared form. So after I rewrite my u squared plus 1, I realize that I can factor this second parentheses using this formula here, a plus b, a minus b, square root the things and put a plus and minus in there. So square root of u squared is going to be u, and square root of 4 gives me a 2, and then I can also write u minus 2. All right, so let me see if I can find that answer. There's my u squared plus 1, there's my plus 2 and my minus 2, so that's an r that I need. So then 9 right here is going to be an r, and that's the only 9. For number 10, I'm going to have to probably use AC method at some point, but before I do that, I notice these all have u's. In fact, the smallest one is u to the second power. So I'm going to start by taking out u squared. That leaves me with 15u squared plus 2u to the first power, we're subtracting the exponents, minus u squared over itself is just minus 1. So let me use AC method on the stuff in there. 15 times negative 1 gives me negative 15. So I need factors of negative 15 that add up positive 2. 1 and 15 won't do it, but 3 and 5 could work if I have a negative 3 and a positive 5. So I'll split this up into negative 3u plus 5u for that term right there, that 2u. And moving forward now, I can do some grouping on my stuff inside. So I have 15u squared. I've got the u squared that I took out initially. Don't want to forget that. But in here now, I can take a 3 and a u out of those first two terms. 15 over 3 is 5. U squared over u is u, so 5u. 3u divided by itself, we've got a minus 1 there. And for the next two terms, 5u and minus 1, I can't take anything out of that other than a 1, so that's what I'm going to do. And that leaves me again with 5u minus 1. So just to recap, I have that u squared from the beginning, and now 5u minus 1, that common factor can come out of everything, and then 3u plus 1 is my leftovers for that last factor. Let me find that over on the left. Here's a u squared, 5u minus 1, 3u plus 1, that's what I need, first one, h. So that's going in spot 10 right there. And it turns out if you keep looking, there's also another 10 down here, so that also gets an h. This next problem looks even crazier than the last few because now I have a u and a v going on with some of these. Let me see what factors I can take out of here. So for numbers, it looks like I can take a 2 out of each of these, 2, 18, and 28. Now how about for letters? Do they all have a u? They do not, only the first two do. But all three of these have v's. So I'll take out a v, and then I basically don't have to worry about v for the rest of the problem. So taking a 2v out of the first thing, 2's cancel, v's cancel, that's just a u squared left over there. Let's see, negative 18 over 2 is negative 9, and the v cancels there as well, so we have a negative 9u. And then 28v, v cancels, 28 over 2 gives me a plus 14. Well, the inside stuff doesn't look so bad. I just need factors of 14 that add up to negative 9. So 1 and 14 won't work, but 2 and 7 works if they're both negative. So I've got the 2v from the beginning. I've got a u minus 2 and a u minus 7. Let's see here. 2v, u minus 7, u minus 2. Looks like that's everything I need. So that's n. So spot number 11, there's only one of those right there. That's an n. For number 12, what common factors could I take out of this one? We have a 12, a 36, a 27. Those are at least divisible by 3, and I think that's as good as it gets. I'd like to take out a 6 or a 12, but this 27 is kind of messing up my game there. So take out a 3. These all have at least a u to the first power, so I'll take out one of those as well. And then 12 over 3 is 4. U cubed over u is u squared. Next, 36 divided by 3 is a plus 12. And then u squared divided by u is just u. And then the u's cancel for this last one. 27 over 3 gives me a plus 9. I could use AC method on the stuff inside here, but I happen to notice that 4u squared and 9 are both perfect squares. So this might be one of those perfect square sandwich situations. For example, this might be an a squared plus 2ab plus b squared that gives me a plus b squared. I don't know for sure, but I'm going to try it out. So again, to use this shortcut, you essentially square root the first and the last terms, put it together in this format, and then check the middle term to make sure it actually works. So I've got the 3u initially. Square root of 4u squared is going to be 2u. Square root of 9 is 3. Use the sign of the middle, so this is a plus 3. Whole thing squared. And then let me multiply out 2u and 3 and double that. 2 times 2u is 4u, times 3 is going to be 12u, so that does match the middle term. This little check here confirms that this is actually the correct factorization. So that was much nicer than using AC method. And now let me see if I can find that over here on the left. It looks like that's all the way down here at the very bottom, O. That gives me everything I need. So in spot 12, I've got an O right there. And if I search a little further, there's another 12 right there, so there's another O, and a third O right there. So we got a lot of use out of the O. We're getting close now, just 2 problems left. Let's forge ahead with this one. These terms all look like they're divisible by 5, so let me take that out, and I don't think I can do much better than that. So 40 becomes an 8 with a u squared. 15 over 5 is going to be a plus 3 with a u. And then 55 over 5, we have minus 11. Can't really do much else in here other than AC method. 8 times negative 11 is negative 88. So I need factors of negative 88 that add up to 3. 1 and 88 doesn't work. 2 and 44 doesn't work. What else do we have? 4 and 22. Getting closer, but that still doesn't work. I don't know about 7, but 8 and 11 gives me 88. And if I had a negative 8 and a positive 11, that would add up to 3. So let me split that up into a negative 8u and a plus 11u for that middle term. So now using a little grouping, I've got the 5 that I initially took out. 8u squared and 8u, I can take an 8 and a u out of both of those. So that first term now is just going to be a u. Negative 8u divided by 8u is a minus 1, so that's nice. For the next two terms, definitely can take out an 11, leaving me with a u and a minus 1 again. So there's the 5 I took out before. U minus 1 comes out as a common factor, and then 8u plus 11 is my other factor. Looking for that setup on the left side now, I've got the 5, I've got the 8u plus 11, and the u minus 1. So I need a p going in spot number 13. There's a 13, that gets a p, and you get a p, and that's about it. Alrighty, we saved the best for last, number 14. This is one of those quadratic form deals where I can factor it like a quadratic using u squared instead of u. So I need factors of 9 that add up to negative 10. That would be 1 and 9, both negative. So I have u squared minus 1 and u squared minus 9. Now these are both differences of squares, so I can use my a plus b, a minus b shortcut on these. Square root of u squared is u, square root of 1 is 1, so I have u plus 1, no, minus 1, plus 1, either way, doesn't matter what order I write it in. And then this next one I have a u plus and minus 3, so minus 3 plus 3. And if I look down here, it looks like that's going to be choice L. So we have an L going for the 14, another 14, and 2 more 14s here. I'm ready to solve the puzzle. For the first one, we have old lawyers never die, they just lose their appeal. And then old skiers never die, they just go downhill. There it is, Mr. Sutton signing off.